In this video, we will be taking a look at how to install and run the UKU simulation. In the previous video, we cloned and sourced the simulation workspace. Now let's start the UKU vehicle launch file from the UKU vehicle Gazebo package. This launch file includes everything required for successfully running the simulation. If everything has been done correctly, two new windows should open, named Gazebo and RVs. Let's start with Gazebo. Gazebo is a free open source simulator already included with ROS. Make sure UKU robot gets automatically loaded. Gazebo has a convenient graphical user interface for manipulating the virtual world. Let's start by adding a light source from the top menu and moving it above our vehicle. Different button combinations can be used for moving around the simulation. Let's take a look at the robot model defined in the URDF file we inspected in the previous video. Here we can also spot the virtual LiDAR and camera sensors. Let's use the GUI to place different obstacles in our way. When that is done, let's open RVs that was also included in the launch file. RVs is a free open source visualization tool included with ROS. Here we can see exactly what the robot sees, no matter if the robot is real or running in a simulation. In the main window, we can see a visualization of the point cloud from the top-mounted laser scanner. This gives us a good idea on how the robot perceives our previously placed obstacles. On the bottom left, there is also a window displaying the camera picture. The visualization is fully customizable. Elements can be added, removed, edited, and toggled on or off from the top left panel. Let's open up a new terminal and run the keyboard teleoperation node from the Ackermann drive teleop package. Let's also run RQT graph to see the node connections. As we can see, the Ackermann drive key-up node listens to our key presses in the terminal and publishes driving and steering commands to the vehicle. Let's try manually driving by looking at the vehicle's perception. We can also see how the robot is actually driving by looking at the simulator. The complexity of a simulation can go really deep. For example, all the objects we have placed are dynamic and will react to forces applied to them. The robot model also simulates suspension and friction. The main idea of a simulator is to aid development and testing of our code before trying it on the actual robot, which is especially useful for big mobile robots like UKU. Thank you for watching.